Hello, I'm David Noel. Welcome to episode 06 of SMB. The topic today is solar systems, that is, stars and planets. This is another area where a very different understanding has emerged over recent years. Until 1992, our Sun was the only star known to be accompanied by planets. Now we know of thousands of planets associated with other stars, so-called exoplanets. Let's look briefly at the old and the new picture. When the only solar system known about was our own, with our Sun accompanied by planets and moons, it was natural to assume that all the parts of the system were formed in a single process. Here is an artist's representation of our solar system. The Sun is in the centre of a wide disk with the planets circling the Sun. A popular idea has been that the planets aggregated from a loose disk of material formed around the Sun at the time of its own aggregation. This is a nice concept, but when examined closely, it just falls apart. There are all sorts of things wrong with the protoplanetary disk idea. Let's look at some of these weak points. First, we have a good understanding of gravitational forces and their effects and abilities, but there's no way known that gravity could form a loose disk like that imagined, or that it could persist around a star. Second, even if such a disk could exist, there's no reason why the plane of the disk should coincide with the equatorial plane of the star. The third difficulty comes from our knowledge of the increasing numbers of exoplanets found. Many of these are what is known as hot Jupiters, planets as big as Jupiter existing very close to their stars, some closer than Mercury is to the Sun. The problem here is that a protoplanetary disk just could not hold enough material that close to the star for a large planet to be formed. Another problem is the existence of so-called rogue planets, planets existing without an adjacent star. These are hard to detect, although quite a few are known. All these problems disappear with the arrival of a new concept for formation of planets, moons, and stars. This concept is simply that most celestial bodies form independently in space. That is, while stars and planets may form in the same epoch of time, they form independently by gravitational aggregation of matter from the interstellar medium. So, if these bodies formed independently in space, why have they ended up like the solar system, with planets orbiting in the same plane, the Sun's equatorial plane? The answer lies in a gravitational force called equatorial forcing. This says if a smaller bodies are orbiting a massive central body, the massive body will exert a gravitational force on the smaller ones so that they slowly adopt the same direction and plane of rotation as the larger one. So equatorial forcing has gradually forced all the planets down into the plane of rotation of the Sun. This was a slow process, taking over 1 billion years, and is still not complete. All the planetary orbits in the solar system are still a few degrees tilted. The equatorial forcing process is more marked the closer the objects are to the central body. In this graphic, the orbits of the planets are shown on the bottom left. They are almost in the flat plane. In the centre is shown the Kuiper belt, the region beyond the planets and out towards the edge of the spherical solar system. This belt contains numerous dwarf planets and short-period comets, which also orbit the Sun but have orbits tilted as much as 30 degrees to the Sun's equatorial plane. Beyond the Kuiper belt, there are numerous comets and asteroid-like objects which also orbit the Sun, but with orbits tilted at any degree, any angle. Equatorial forcing is a type of spin gravity, describing gravitational forces between rotating bodies. It's a consequence of Einstein's general theory of relativity, where it's called frame dragging. Equatorial forcing also acts at both smaller and larger scales than solar systems. A beautiful example is in the rings of Saturn. Here the flocks of small icebergs in the ring systems orbit exactly above Saturn's equatorial plane. Jupiter and the outer planets all have systems of moons orbiting close to their planet's equatorial plane, as you'd expect. But no one has suggested that these form from proto-moon disks. In our Milky Way galaxy, the disk shape is because of equatorial forcing acting from the supermassive black hole at the galaxy's centre. The protoplanetary disk idea for solar systems is understandable. Examples of what appear to be disks are actually visible around some star systems. But these are systems old enough for equatorial forcing to have drawn randomly inclined orbits down close to the star's own equatorial plane. So our conclusion is that stars, planets, moons, and other objects in space are formed independently. Following is a link to a referenced article on the web which gives more detail and links on the current topic. And finally, some links to other sources available to you, both episodes on our YouTube channel and a website including articles which quote established and referenced data. Have a look. So it's goodbye from me, David Noel. I hope you like these short efforts to make the universe a bit simpler to understand. Goodbye.